date. And slowly but surely, there we go. All right, so there are a few theorems. We're not really going to prove any of the theorems, but we're going to walk through the ideas underlying the theorems. So the first theorem states, if two sides of a triangle are not congruent. So in other words, I see that these two sides of the triangle are not congruent. Then the angles opposite them are not congruent. So if I look at that angle and I look at this angle, these are not congruent. Okay, so that makes kind of good sense. Let's go ahead and write that out. Just make sure that we understand the thought process behind it. So we have the fact that 45 is greater than 35. So the lengths of those sides in relation to each other. So that means AC, the line segment AC, is greater than the line segment AB. And so as a result, what this theorem is telling you is that the measure of angle B, and I'm going to put my little arc through the angle symbol so it doesn't get confused with the inequality symbol, the less than greater than symbol. The measure of angle B is not congruent, but even more so is greater than the measure of angle C. So which is the largest of those two angles? B. So this is the largest of the two. Or I should say larger, because we don't really know. And this is the smaller angle. So if you're given the following diagram and you're asked to write the measures in the triangle in order from least to greatest. So I would first, if I'm writing least to greatest, perhaps I start with least, and I'm going to greatest. Let's put the order of the measure of the sides from least to greatest. The smallest side is 7. So that is segment AC. And the angle corresponding to that is measure of angle T. And then I have that being smaller, right, than, which is the next one in line. 10, very good, right? Which is segment AT. And what angle is opposite that side? Okay. Which is smaller than the greatest side, which is 11, right? Which is side CT. And what angle is opposite that? The measure of angle A. Good. So if you're asked to write the measures in the triangle in order from least to greatest, there it is. Now let's look at another theorem, the converse of the previous theorem. This theorem says, well, if I have two angles of a triangle that are not congruent, then the sides opposite them are not congruent. And the longer side is opposite the larger angle. Okay, so let's go ahead and look at the largest angle. So the largest angle is this one. So the side that is opposite that is going to be the largest side, which is the smallest angle. Okay, very good. So the side opposite that is going to be the smallest side. So we can write that out. So we have the largest side, it's BC, which we obtained from the largest angle. Well, let me put that in reversed order. So the largest angle is the measure of angle A, which implies the longest or largest side is BC. And then similarly, the smallest angle is the measure of angle B, which implies the smallest side is AC. So in the first theorem, we start with the length of the sides, and then draw conclusions about the opposite angles from those sides. And in the second theorem, it's the converse. We're starting with the measure of the angles, which gives us information that we can deduce about the sides. Now, some little corollaries that are quite interesting and very useful, especially when you get to linear algebra and we start looking at projecting things from off the ground onto the surface, so to speak. This corollary says a perpendicular segment from a point to a line. So let me look at a point. Let's say I have a point here. And let's say I have a line here. So a perpendicular segment would be this. A perpendicular segment from a point to a line is the shortest segment from a point to a line. So that means any other line I draw from the point to that line, any other line segment is going to be longer. So the perpendicular segment is the shortest segment. The second corollary says a perpendicular segment now from a point to a plane so there's my little plane. So I have a perpendicular segment from a point to the plane is also the shortest segment. So if I had any other line segment from that point to the plane, it's going to be longer. Any questions on those two corollaries? No? Okay. Now, before I go through the next inequality and continue on, I want to show you, it's like 1 minute, but I have to show you this little video. Yes. Did you watch it already? I mean, it's just, I found it and I thought it was super cute. So, I mean, you know, I got to share. I think for me, I like to see things. So I prefer to visually see theorems when I can, or build them, construct them with our patty paper instead of just reading the words. So let's just take a tiny peek. It's only a minute long, but I think it'll walk us through the next theorem. it go? Where'd it go? Oh no. Oh no, 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 no. Hang on. I lost our little, I lost our, back it up and start over, because I want to make sure everybody online can see it as well. Where's my little video? Y'all are seeing it, but I don't know if they'll see it. Bella, can you see this?
No.
I don't think she can. Hang on. Sorry. All this just so you can see this cute, this little silly video. Hang on. No. Where is my team meeting? Where's my video? Oh no. How am I going to get to show you this? There's the video. Oh my goodness gracious. Okay, I'm going to show it in here, but how do I get it in a Teams meeting? That is the question. Can y'all see that online?
Yes.
Yes? I'm playing it. How come I don't hear it? Oh well. So this is the triangle inequality theorem. It says the sum of any two sides of a triangle is greater than the length of the third side. So if you don't have two sides of a triangle being greater than the length of the third side, you don't have a triangle. So this is the next inequality. Now, do all pairs have to add up to be longer than the third side? No, but one pair must. So do you see how sum of these two is longer than this? Even though the sum of these two isn't longer than this and the sum of these two isn't longer than this, as long as we have one pair, sum being longer than the other two, then we're good. Yes, sir, Jackson. That's a very interesting question. Does it say greater than or equal to, or does it just say greater than? Just greater than. Okay, so let me come back here and let's go back to our notes. I don't know, I thought that was cute to see. Hopefully you thought it was cute. Oh no, now it's still talking to us. Hang on, hang on. Oh my goodness gracious.
Well, if you want to make this small, you really...
Okay. Now let me quit here. No, I do want to show this. Okay, we're good. Everybody can see everything they're supposed to see. Oh my goodness gracious. All right, so what did that triangle, all of that for just our little triangle inequality theorem. Our triangle inequality theorem again says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Okay, so if I were to give you three potential side lengths, can you tell me if it is a triangle? Are these sides to a triangle? Again, You have to have just one pair sum to be greater than the third. Not all pairs, not all combinations, but at least one pair. So if I look at the first example, I see 3 plus 6 equals 9. Uh-oh, 9 isn't greater than 9. So this is not a triangle, right? Because the sum would have to be greater than the third. All right, let's look at the next one. 4 plus 5 equals 9. Oh, equals 8, sorry. Is 9 greater than 8? Yes, so this is a triangle. Let's look at the next one. 2 plus 3. Actually, this is what we're wondering. So then I have 5, but 5 is not greater than 8. So therefore, is it a triangle? Not a triangle. And looking at the next one, is that greater than 8? Yeah, so this is a triangle. So again, as long as one pair of two sides can sum to be greater than the third, then you have a triangle. So what if in the next example, and there's a little typo in here, find the possible side lengths of a triangle if two sides are 5 and 9. So here I have two sides, 5 and 9. What would be a possible third length? Excellent. So I can actually set up an inequality. I can say 5 plus x, right, if I chose these two, would have to be greater than 9. Or 9 plus x would have to be greater than 5. Or 5 plus 9 would have to be greater than x. So if I just used simple algebra, I could get the value of x, that would make values, I should say, that make this true. And then this would be x is less than 14. So if I look at this on a number line, I have -4, I have 4, and I have 14. So if I were to look at the relationship to where each of these would appear on the number line, for this one, x is greater than 4, it would be that, and I should do an open circle here, right? Greater than 4. If I had, let me just do the lines because it's going to get kind of messy. So for this one, I have this. For this one, I have this. And last but not least, for this one, I'm here. So if I look for when this is possibly true, first of all, we're looking at lengths of a triangle. What can you tell me about lengths? They can never be negative. So I have to throw out all the values that are negative, right, for starters. Well, if I look at what overlaps, what is shared by each of these lines? Only the values between 4 and 14. Right? So those are the possible lengths, all values between 4 and 14. So I can write that graphically, or I could write it as a compound inequality. 4 is less than x is less than 14. That's another way to represent the same information. So that third length can be any number between 4 and 14. Now, if I want to generalize that for any side of a triangle, the difference of any two sides is less than the length of the third side, which is less than the sum of the other two sides. So, for example, I could give you the difference of any two sides. Let's say 11 minus 6 is less than the length of some third side, x, which is less than the sum. So do you see how I set up that compound inequality using that information? So if I were to simplify this, what would this first expression give me? 5 is less than x, which is less than. So we would say that the lengths could be between 5 and 17, right? On the number line, if we were to look at that. I'm sorry? And. Oh, well, I kind of did it up here after I wrote it. In between, it can't be 5 and 17, right? It has to be a number in between. So I kind of did that one here. Do we want to do the one that was given up above, or are we okay with this theory? We're okay? All right, there's some hinge theorems, some little things that kind of rely on that on the previous information. You should, I believe, already be familiar with the side angle side equality theorem. So the side angle side inequality theorem says if two sides of one triangle are congruent to two sides of another triangle, okay, graphically, what does that mean? This one is congruent to this one. This one is congruent to this one. So if two sides of one triangle are congruent to two sides of another triangle, but the included angle of the first triangle, so there's the included angle of the first triangle, is what? Larger than the included angle of the second triangle, then the third side of the first triangle is longer than the third side of the second triangle. Okay, so let's put a little bit more information in here. I see the congruencies of the two sides. I see here, if I want to say, let's go ahead and write that out. If AB is congruent to DE, right? So AB is congruent to DE, and we have two other congruent ones. BC is congruent to EF. So BC is congruent to EF, and we have the measure of angle B is greater than the measure of angle E. So I'm just taking everything that they've given me and I'm labeling it accordingly. So measure of angle B is greater than measure of angle E. Then this theorem tells us what? What do we know about this side? Beautiful. AC is greater than DF. Any questions on that one? Okay, let's look at the next example. So we have, what do we know about this? Well, we know that these two, right, that's congruent to itself. I have that, let's go ahead and say if RS is congruent to RT. So RS is congruent to RT. And we have the measure of angle 1 is greater than, let me put that down below. Is greater than the measure of angle 2. So measure of angle 1 is greater than the measure of angle 2. Then what do I know? What? Give me the line segments. SV is greater than PV. Again, because we look at the opposite sides. Right, because there's two separate little triangles. Okay, now we have the side-side inequality theorem. That says if two, and that should be sides, if two sides of one triangle are congruent to two sides of another triangle, okay, we're back to this. So I have, this is congruent to this. So if AB is congruent to DE and BC is congruent to EF. So I have two sides of one triangle are congruent to two sides of another triangle, but the third side of the first triangle is longer than the third side of the second triangle. So then I have, and what? AC is greater than DF. Then what do I know? Then the measure of angle B, how does this compare to this? Yes. Measure of angle B is larger than the measure of angle E. That's all that says. Now, if we take into consideration those two corollaries where we said that the shortest length, shortest distance from a point to a line or a point to a plane is that perpendicular line, then this would be 90 degrees, and this would be larger than 90 degrees. So in this case, this DG would be smaller than DF. So they're just showing you that with respect to these, right? Because this would be the same. Okay, let's do some examples. We have a few examples that will put all this information together. See if we can draw conclusions using these theorems and corollaries. Okay, so again, and I have to commend you. Y'all did a great job of labeling your diagrams and showing your work for the most part. I mean, your labeling, it was tremendous on the test. That was excellent. I don't know how y'all approach these things, but when I read theorems and I read things, I label things immediately and write down what I know, and y'all did an exceptional job of that. Okay, so this one, I see the following segments being congruent. Okay, so if I look at this and I see these, I want to compare this angle to this angle. Can you tell me, obviously, these two, that's terrible. So I see two little triangles, right? What can you tell me about the measure of angle 1 compared to the measure of angle 2? And how do you know that? That's right. So if I look at this one, its opposite side is 4. If I look at this one, its opposite side is 3. And since 4 is greater than 3, the measure of angle 1 is greater than the measure of angle 2. Excellent. And we have side, side, side inequality, right? Okay, now let's look at this one. Ooh, doing good. Let's see what we know. Okay, I see these two are congruent. And I see they share that side. So I'm investigating some angles. So first of all, can we say anything looking at these angles? This one, which is greater than 90 degrees, and this one, which is 90 degrees. If I look at the sides opposite those angles, can we say anything about this? AD is smaller than AB. I agree with you. Side angle, side inequality. Any questions on that one? No? Okay, now let's look at these other angles, these other two that involve angles. I have the measure of angle CAD, CAD. So I'm looking at this angle, the measure of angle CAD, and I'm looking at the measure of angle D. What can you tell me about those? And how do you know that? Because how would we describe this? This is a right triangle, so how would I describe that side? What do we say? I mean, you said it was the longest one. What is that? That is the hypotenuse, right? So I know it's the longest. Excellent. Now let's look at the measure of angle B. So I have the measure of angle B. I'm running out of colors.
Wait, Dr. P.
Measure of angle B. And how does that compare to the measure of angle BAC? Oops, sorry. Measure of angle B is less than. Ugh. Excellent. Any questions on those? No? They're pretty straightforward? Okay. So you have, oh, we have a question online. Do we have a question online?
I have a question.
Yes? No?